All right, here's what I want you to do. Put the video on pause, set up your notes just like you see here on the screen, and then we'll come back and we'll take some notes on piecewise defined functions, and then you'll try some homework problems, and then you'll come back, do video 2, and you'll fill in some notes right here about step functions and greatest integer functions, and then you'll try some problems, and then you'll come back, and then we'll try the absolute value function. All right, thank you for taking notes. All right, let's get going. So we're going to come back to this question about what is a function. We've talked a little bit about it already. You might feel like you've got a pretty good handle on that, but we'll come back to this idea here after we look at this graph. So I don't know if you've ever heard in sports or not that your eyes are super important, that what you're focused on, they'll have some keys to watch. And they'll say that, a guy's eyes were in the wrong place, and then they'll get beat on defense, or a lot of different scenarios for all different kinds of sports. But that's quite often something I hear. And you might say, well, what does that have to do with math? Well, your eyes really need to focus first on this part of the definition of this function. This part right over here is telling you what the domain is. So what I want you to do is circle that and really focus on that for just a second. So when I say focus on it, we're going to look at it and say, well, x is less than or equal to 1. Okay, so 1 is an important place in our domain. So let's mark that on our number line, 1. And for all the numbers that are less than or equal to it, it's going to be defined by this function right here, x minus 3. So let's think about y equals x minus 3 for a second. For this part of our graph right over here, it's going to be defined by y equals x minus 3. So you might say, well, what's up with all this other stuff? Like what's up with, everything else that's over here, like f of x? So this f of x represents y, but there's two functions over here. There's like a function number 1 and there's a function number 2. So the curly bracket is saying, hey, here are all the functions that we have to worry about. So on function number 1, I'm going to try to graph it right now. That's like step 1. You have really 2 steps in this problem. Oh my goodness. You have saying 2 steps, and I wrote step 2. We're on step 1 right now. We're focused on x minus 3. So how do we graph that? Well, we're going to go down 3 spots, 1, 2, 3. Since it's in slope-intercept form, I'm going to use the y-intercept. So that's at -3, okay? And then the slope is 1. So I'm going to go up 1, over 1, and I'm going to put a solid dot right here. Now, why am I putting a solid dot? Because it says less than or equal to 1. If it would have just said less than 1, I would have put an open circle right here. The line is not going to do this. The line is not going to keep on going over here. It is going to only go, let me erase some of the line. It's only going to go out to that solid dot that I just put there, because the function is defined for less than or equal to 1 as x minus 3. If we're greater than 1, then the function is defined as 2x. So let's go and graph 2x now. So here comes step 2. Step 2 is going to be for this part of the graph over here. Step 2 is to graph y equals 2x. Okay, so let's go up here to 0, 0, 0, okay, because it's a plus 0. And I'm going to make it have a slope of 2. So I'm going to go up 1, 2 over 1. Okay, I'll come back to this idea in just a second. I'm going to go up another 2, 1, 2. So I'm going up 1, 2, and I'm going to go over another 1. So let's put that dot right there, okay? And now I'm going to graph my line. And I know what some people might be saying. Wait a minute, Nelson, you said the function is only defined for x greater than 1. That's why I've got this little curly bracket here. This is for x greater than 1. And this was for x less than or equal to 1. So what do I need to do? I'm going to grab my eraser and I'm going to erase some of this line. In fact, I'm going to erase even that dot right there, because what I want to do is I want to put an open circle right here, because my function's only good for the stuff to the right of 1. Now, in this first video, I want to show you also how Desmos can do the same thing, but Desmos really lacks the ability to put this open circle right here. And honestly, you might look at this after I show you on Desmos and say, hey, this isn't, what you're showing me on Desmos is not easier than what we can do just by hand. By hand, it didn't take me that long to graph this. And it's good practice for our slope intercept. That's why we spent so much time yesterday going over how do you graph lines. Now we're only graphing part of the line because it's only defined a certain way. The function is only defined a certain way over a certain portion of the domain. So let me go to Desmos in just a second after I talk about this idea. So what in the heck is a function again? A function is for each x value, there's only one y value. And we test that with what they call a vertical line test. So I'm going to draw a vertical line right over here. And I should be able to, if it's a function, I should be able to grab that vertical line and move it anywhere I'd like. And it should only cross the graph in one spot. So like right here, it's crossing the graph right here at that one spot. Right here, it's crossing in only one spot. Now, I don't know how accurately I drew this. Right here, it's only graph touching in one spot. It's touching right up there. Now, when I move it right over here, do you see how there's my solid dot's a little bit too far to the right, but there's a solid dot here, and then there's an open circle here. So it's still only crossing in one spot on the function. If it would have had an equal to right here as well, like an equal to and an equal to, then it would have two solid points. Then it wouldn't be a function because it would be hitting here and it'd be hitting down here. So as I move the function further to the left, or not the function, but if I move the vertical line further to the left, it's only hitting the function in one spot. So this is definitely a function because it passes the vertical line test. Now, you've heard me say a lot about the horizontal line test. What's a horizontal line test about? That's to determine if something's a one-to-one function. So let's test that idea out. As I move it up here, it's only touching one spot, only touching one spot. It's not touching the function at all in here, but that's not a problem. It just can't touch the function in more than one spot. So it's, it wasn't touching here. Now it is touching in one spot, the whole way. My eyes focused right there, okay? So, where is it hitting the function? Only in one spot. I know it doesn't hit in here. That makes you nervous maybe, but it only hits in one spot. So it is a one-to-one function. All right. So let's make a little note of that right up here. I want you to add some stuff. We're going to do a vertical line test to see if it is a function. Vertical line test. And that's to see if it is a function. Yes, no on function. You do a horizontal line test if you're worried about one-to-one. I'm not even going to put it in here because I don't think one-to-one is really a main focus for this section. So let's go to Desmos. If you're not interested in seeing how to do this on Desmos, then you just pause the video and you try problems 1 through 4 right now. But I think some people are going to be like, hey, show me how to do this on Desmos. So open up Desmos for me. Open up your calculator. And I know one of the functions was x minus 3, I think, right? So let's go back. Let's just check. Wasn't it x minus 3? Yep, right there's the function. Now we're going to tell it if x is less than or equal to 1. And here's how you do that on Desmos. You put a curly bracket down and you go x less than. Feels like we've done this before, doesn't it? I think we have. Okay, so the wonderful thing that Desmos does, is it restricts the function. We had that line going on forever. Now it's just stopping right there. The thing I don't like about Desmos is it's not really like putting a dot here to show, it goes all the way to 1. And it'll be more obvious on my next I don't think you really need to close the curly bracket down, but I'm going to do it. But on my next function, when I do this, y is equal to 2x, wasn't it? Wasn't that our other function? And then you put the curly bracket in and you go x greater than 1. See how it doesn't put an open circle right there? So that bothers me enough to where I'm going to try and put a point there. So my point is 1, 2. Now you might say, oh, that's a solid point. Yeah, but you can fix that. You can click, you can hold down your mouse and then you can choose an open circle. That's really kind of what I'd like to see right there. I guess we could put another point in there. I probably should make that blue as well. Oh, shoot. Let me try to make it blue. Okay, hold down the mouse. It'll let you, I think. Come on. There we go. And I can change it to blue so it kind of matches that color up there. And then I could put another point in at 1, -2. So let's go 1, -2. I want that point to be closed like it is, but I'd like it to be red in color. So let's see if it'll let me change it to red. Now that would be pretty good in my opinion, but it takes a couple extra steps to put the correct points in there. This is how you do piecewise defined functions on Desmos. All right. Hey, thanks for watching video 1.